Welcome. In this video, I'm going to demonstrate how to find a vector orthogonal to a plane containing three specified points. The points here are 1, 0, 0, 1, 1, 1, and 2, negative 1, 3. So what we need to do is define two vectors in the plane. I decided to use Q to R as my first vector, so here's Q to R. And so QR is given by 3, let me start with the x components. 2 minus 1. The y component is negative 1 minus 1, and the z component is 3 minus 1. That gives us the vector 1, negative 2, 2. You can do the same thing to find, say, QP. You'll get 0, negative 1, negative 1. And now to get a good idea of what you're doing, go ahead and open up GeoGebra. You should be fairly comfortable getting into the 3D graphics view, so I'm not going to show how to do that. And I do tend to hide the XY plane. That's a preference. You don't have to hide it. So let me go ahead and show you the 3 points. I'm going to type in P equals 1, 0, 0. Q equals 1, 1, 1. R equals 2, negative 1, 3. So there are my 3 points. And then the vectors that I define, vector, my first one was Q, R, so Q comma R, and 1, negative 2, 2. That is the same thing we already worked out. And you can visually see the position here of QR. So here's the vector starting at point Q, going to R. We can do the same thing with the vector QP. So I'm going to type in vector Q comma P, and there is QP. And here's the positive y-axis, positive z-axis. You can see the vectors really well there. And here we go. Here's the positive x, y, and z. So here is QP. All right, so let's continue. The reason I wanted to show you these visually is so you can see that these are indeed on a plane. So the plane created by these 3 dots, if I decide to make some vectors using these three points, then I'm going to get vectors in the plane. So both of these are on the same plane. So now I'm going to find the cross product of these two vectors, because the cross product, that is QR cross QP, that's going to be orthogonal to both of those vectors. Since it'll be orthogonal to those vectors, it'll be orthogonal to the plane that these vectors lie in. So QR cross QP, that's equal to, well, let's set up our matrix to figure that out. 1, negative 2, 2, 0, negative 1, 1. Excuse me, negative 1, negative 1. Now, please pause your video and work out what this vector will be independently, please. All right, you should have gotten 4I plus j minus k. If you did not get that, make yourself a note here to redo this, and this gives you vector 4, 1, negative 1. All right, so this vector here is orthogonal. So this vector to the plane containing P, Q, and R, since it's orthogonal to QR and QP. And again, you could have chosen to use any other vectors. I could have used RP or RQ or PQ. I just picked QR and QP. Now, as always, I want to show you what this looks like in GeoGebra in the hopes that you'll hopefully see what you're actually doing a bit better. So please open up GeoGebra. So let's go ahead and type in cross, and then we're going to type in u comma v. So this will give you the cross product of these two vectors. And I want to make sure that this vector is orthogonal to the plane containing these two vectors. So I can just make sure it's orthogonal to, either of these vectors. So I'm going to type in angle. And there are a few options for angle. You can do vector, vector, line, 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 plane, etc. I'm going to do vector, vector, and I'm going to do u, w. There it is. Anyways, it's 90 degrees, and I can do VW as well. And there we go. So here's one more way you can verify this. We can do a plane through 3 points, and we can select this and then select the point P, Q, and R. And there's my plane. And then you can't find an angle between a vector and a plane, but you can find a vector between a line and a plane. So for a line, we need 2 points. So one of our points is the origin. If you notice that point, and also 4, 1, -1, those points make up our vector. And so that you can see it easier, I'm going to hide a few things. I'm going to hide V, U, and I'm going to hide, actually I'll leave the 3 points. So I hid the 2 vectors I used to find this orthogonal vector. But as you can see, here are the 3 points on the plane, and here is the vector orthogonal to this plane, beginning at the origin and going here to B. Okay, so now I'm simply going to, I can click on the points directly, or I can just type in line, and here's the options, and I'm going to do point, and my first point A, comma, B. All right, so that line, as you can see, goes straight through our vector, right there. Okay, so now finally I'm going to do angle. And actually I forget the order. It is line, plane. So angle, and for my line, I'm going to type in F. As you can see, that's the name of this line. And for my plane here, a little P, since that's the name of this plane. And again, it is 90 degrees indeed. And this one is really nice to see. I'm trying to get the angle just right. There we go. So we can see there is the plane. There is, and I'll hide this line. There's our vector, and the angle between the plane and the vector is 90 degrees. And here's in a more standard view. Here's the x-axis, y-axis, z-axis. I'll hide the unnecessary points here. There's P, Q, and R are points on the plane. Here's our vector, and the angle is still 90 degrees.
I hope you found this video helpful.